Hi everyone, happy Wednesday. Welcome to UTA Planetarium's next Facebook live stream. My name is Levent Gurdemir, UTA Planetarium Director, and here with me, Jim Bader, Program Coordinator. Please come and say hi, Jim.
Hey, we're back. It's been a long time, Levent. It's literally been 3 weeks, I think.
It,
Network issues, all kinds of stuff. Very sorry about that, everybody. Really sorry about that. But
it
we're
feels
back.
like a very long time, but last week we were on YouTube. If you
Yeah,
are not following us on YouTube channel, this is also another platform. You can find us. You can find cool space stuff, astronomy stuff. And on Facebook, always, we'll just keep doing as much as we can Wednesday live stream. So let's
definitely.
see. Here is with us today. I see Lamia
Nice.
says, "Welcome back." Thank you very much, Lamia, for your nice comment. And let's see who else is with me. And always, you can ask questions on the chat, interact with us. We received a bunch of questions and bunch of suggestions about what to talk about. We'll talk about those. And in the meantime, please just keep us interrupted with your chats
Yeah,
anytime.
definitely. Interaction with followers is always the best thing. And I know that we certainly weren't consistent with our streams the last few weeks, but we're back. Hopefully for good. We are experiencing network issues today, so hopefully that doesn't bother us. I think we tested and set everything up that we should be clear. But yeah,
Let's talk about what's going on tonight.
there's
So
something going on tonight.
it is October 20, and it is another meteor shower. I don't know if it is going to be a great meteor shower, but
Hey,
Orionids is with us this evening. So Orionids is,
Orionids. Is that like Orion?
yeah, it's Orion. It's very famous constellation, one of the most recognizable constellation of the night sky. It is rising very late though. It is rising after 1 a.m., 2 a.m. Hours, but you can find it in the east
Oof.
direction. And with the rise of Orion, there is some stuff that is remaining from the very famous Halley's Comet. The Halley's Comet sprinkles some particles as it goes in on its orbit, and then those particles happens to be just encountering Earth, our planet, on its orbit every late October, this time of the year. And the direction to see it, you find Orion constellation, and then you hopefully you may see some shooting stars in the sky. So well, there's a full moon interfering with the meteor showers. Full moons are always problem for observers because the sky is too bright, too lit. You may not be able to see dim events in the night sky. So the full moon is not going to be allowing for a great meteor shower. And but still, you may catch a few meteors in the sky, hopefully.
Yeah, yeah, definitely. Um, Regardless of the moon, you can still see them. You just have to be really patient, right?
Yeah. And hello, Janet. We missed you too. You always watch our videos. You're a great viewer. And speaking about meteor showers and meteors, we talked a lot about what are they exactly. I'm holding a meteor right now, and this meteor is, it's a very heavy piece of rock. We know it's
Meteorite.
meteorite. i'm not
I'm
gonna
sorry. I'm
i'm not
sorry. I'm
gonna
sorry.
I'm not gonna say this joke. There is no like meteor wrongs. All of them are meteorites. But anyway, meteorites are funny things, and that they fall from sky. They fall from sky, and sometimes they land on strange places. Well, most of the time, if we think about our planet, 75% of our planet is covered by water. So
Yep. Yep.
likely 75% of the time, by statistics, they are going to land on water and never be found.
But there was
Well,
that one time, I think it was like in the 90s, somebody in like Massachusetts or Delaware or something, it hit their It landed in their living room. Somebody else had their car hit by one in Georgia or
Mhm.
something like that. It
Yeah, I seen the
happens.
car, and it was fantastic car though. It's a classic car, landed on, and I think it was just a damaged fender, if I remember
It's a
correctly.
pretty good
But
dent.
recently, the one in actually landed on a bed in a room. So, I mean, this is very rare event. There is nothing to worry about, I would think. I mean, there's always chance, but the chance is what? Like maybe less than a winning lottery.
Yeah.
But broke the roof. That's why I think we need stronger roofs because things can come from space. The chance is small, but a satellite can fall from space, and apparently a rock can fall from space and break the roof. And here it's landing on a bed. Luckily, no one is injured because nobody was sleeping on that side of the bed.
But they were sleeping in the bed. That's the crazy part. Ruth Hamilton of Golden, British Columbia, was awoken by the sound, a loud noise, a really loud noise, and she rolls over, um, uh, and then feels scared because of the noise. Calls 911 because of the noise, and then realizes there is a big rock in her bed right between the two pillows next to her. That's just crazy to me. You roll over. So this is where it gets really funny, Levent. I don't know how far you read into this, but after calling the police came to her house and said, "We think this is probably from an explosion at a nearby construction site." So the police contacted the construction people, and they said, "No, we haven't had any explosions since yesterday, but we did see a bright flash of light in the sky a little while ago." And that's how they were quickly let on that it was a meteorite. That's just, it's crazy. It blows my mind.
That's amazing.
Um,
Well, I think the black color explains us it was on fire.
it was on
And
fire.
it must be pretty
I can,
hot at the time it
I can
fell on the
slide this
bed.
down a little bit. Here's Ruth Hamilton, that just got missed by a meteor woman. Extremely lucky. This is just wild. It's 2.8 pounds and supposed to be about the size of a meteor, or sorry, a small cabbage.
Well, I'm glad this time it's rock because about a decade ago, I remember a story. Similar thing happened. Something fell from sky that was pretty much looked like a frozen ice. And the family actually kept it for some time in the fridge before some scientists arrived to inspect to see what's going on. And it turned out to be not a rock from space. That one was actually an illegal dumping, a toilet dumping from an airplane. So they kept it in the fridge for a week, unfortunately.
It's
But this one is not.
disgusting.
This one is
No.
confirmed to be a
Yeah,
meteorite.
it was confirmed by multiple universities, and other scientists confirmed it. The primary investigator on this was somebody named Professor Alan Hildebrand from the University of Calgary's Department of Geoscience.
Yeah.
Um,
Well, time to time, people find weird shape rocks that look different from others in the field, and they bring it to us, to the planetarium, and say, "Hey, I found something different. Can you just tell me whether it's a meteorite?" It's not easy to by just directly looking at it. It is not easy to tell if it's something from Earth or from space. There may be some indicators, but still, the final confirmation requires chemical decomposition of the rock. And detailed chemical analysis will give the idea that, yeah, that belongs to Earth or doesn't belong to Earth, looks like it's from the moon or Mars or some other planet.
Very interesting.
Hi, Brexton. Good to see you again.
Brexton says cool rock.
Cool rock.
Is
Yeah.
he late? Did he must have popped in late. Must have popped in late on this. Not just a rock. It's not a rock, Brexton. It's a meteorite. Is that a rock? It's probably still a rock. Anyway, yeah. So some other small tidbits about this event that I thought were crazy. So another professor who studies small bodies in the solar system, or let me read that line.
Mhm.
A planetary bodies professor said that the chance of this happening was 1 in 100 billion per year.
Yeah. Well,
So small.
again, probably smaller than chance of winning lottery.
Yeah, I say so.
And do I read it correctly? Somebody valued the meteor between $50,000 and $127,000.
Yes. So let me preface this. I read into this because I saw the number and I thought that's stupid. It's iron from space. So is all the iron on Earth. It's from space, right? I mean, technically it came from somewhere first.
So money coming from space.
Yeah, but here this is what I found out, that the collectors, people who just like to buy things, people who have a lot of money to spend, they really, really like collecting meteors that hit stuff. And when a meteor hits something, like a building or a rock or a car, it becomes very valuable to the meteor collecting group of people.
I wonder what's the value of this.
But it's, I mean, 50K, that could be a lens for a projector. Brexton, how much would a moon rock go for? Depends on how big it is, honestly. But you can buy little chunks of it. They're pretty expensive, but you can buy little tiny chunks, I think.
Well, NASA have loaner moon rocks. They are pretty tiny, come in these type of sizes. But the requirement to get one of those for a museum or a university is pretty tight, because the security requirements are like you have to have a very safe and leave it at the safe overnight and
why
have
they
a
call it
security
that.
guard during the daytime. So it wasn't worth it. We looked into that. It wasn't worth it.
Janet asked a really, really good question, Levent.
Could it have could have started a fire? Yeah, because they come as burning in the sky. I don't know how hot it was. It was definitely hot because it was burning. All the black color.
Before, but
just
it would have left a mark on the bed. I mean, there's no burn.
That's what I was surprised, actually. It came so hot, but you know, I was expecting to see some burn marks on the bed at least.
I think they cool off when they come into the lower atmosphere.
But also, you know, sometimes meteors, they enter into the atmosphere, and when traveling, they are so big and they get so hot and they explode, break into pieces. And then the smaller pieces gain speed and may cool down. So they may actually, this may be the case for this one. Maybe it exploded in the sky, and then just the fire stopped, and it actually landed on the bed after it cooled down. So that's also a possibility too. I mean, still it would be still hot from the friction, but not on fire at the time it broke into the roof.
Yeah, all these images we're using are from Ruth Hamilton herself. So just if you're curious, that's where we got them. Brexton has a question.
Could moon rocks fall through Earth's atmosphere and survive? Yeah, it could be from the moon as well, because if we are wondering like where are these rocks coming from, some of them are coming from asteroids. Asteroids there are like tons of it between Mars and Jupiter, but there is no strict boundary for them. Some of them even are found around the vicinity of Earth. So astronauts is a potential for meteorites, but also an asteroid may hit to the moon or Mars. When they collide with other planets or moons, they also rip a chunk, and that chunk flies into space, just ejected to the space, and then become another asteroid. And that asteroid, which was originally part of Moon or Mars, may also land on Earth in the future. So yeah, possibly moon rocks. Actually, most of the meteorites we are finding, they look like they are from the moon or they are from the Mars. And sometimes we just find iron-rich meteorites, which are pretty much like asteroids.
The golden meteor, the one we just saw pictures of, that one was at least confirmed by those scientists who looked at it, they said that it was one from asteroid and likely from just meteor shower particles. So
Yeah. And
anyway,
some asteroids in the solar system, we know that they contain a big amount of diamonds. So if one of those fall, I think it will have a great value.
yeah.
That actually started the astro mining business. If you heard of some of the space agencies, like European Space Agency, for example, designing some robots that will fly to an asteroid, and they will mine some of the important elements, like it may be diamond or uranium or some others, and bring them back to Earth. So that's going to be another way of getting very expensive materials down to Earth.
It's an idea. All right, we got another question from Brexton.
How big was the meteor that hit in Arizona? It was the size of a 767 jet, not 737. It was slightly, if I say 150 feet or 160 feet, you can check. But I remember that was initially estimated the size of a 767 Boeing jet. Fell from sky at an extreme speed, somewhere around like 20,000 miles per hour. Then that created that hole. So yeah, I mean the meteors don't have to be very big to begin with to make such a hole or crater on the ground.
So meteorcrater.com, which is the official Barringer Meteor Crater website, claims that the rock was traveling at speeds of over 26,000 miles per hour. It was 150 foot wide and weighed 300,000 tons.
Yeah. So the physics says the impact, the magnitude of impact, which is called momentum, is mass and speed. So you may have a small mass traveling, but if the speed is greater, so the impact magnitude is going up. And the opposite is true too. The opposite one is actually, we usually see it on the trains. Trains may be traveling at low speed, like sometimes 25 miles per hour, but still when train impacts to a brick wall, that wall is still destroyed because of the big mass of the train.
Yeah, the wall's not gonna make it.
Have you guys visited the Arizona? It's awesome. I did. I was traveling through Arizona, and I happened to visit the crater, and also I visited Flagstaff. I wanted to see also the Naval Observatory over there, but I realized it's not open to public. And as a public, I couldn't gain access to the Naval Observatory. But I did visit this crater, and it's cool. It's pretty cool.
Definitely. All right. Next story, Levent. Earlier this month, we had reports, a paper that was published that said there was a mysterious flashing radio signal from near the center of the Milky Way galaxy. Yeah.
Sounds interesting. I like signals, mystery signals.
It was very well studied. It was first discovered from the
is that the telescope?
That's the first one that found it. Yeah, it was first noticed by the ASCAP telescopes. This is an Australian radio telescope array. You can see.
Okay, what did the signal look like or sound like?
Yeah. So it was a flashing radio signal that had a circular polarization. Do you want to decode that for all of our viewers?
Of course. I love doing that. So it's probably
what does that mean?
Some alien transmission, perhaps.
That's what they thought. Well, some scientists thought that initially. They were actually kind of like, we need to send this everywhere and get it looked at immediately. So it did. Lamia says there's a black hole. That's what they thought. That's one of them. They were checking everything. This is kind of wild. So when they first discovered this, Levent, they sent it and requested to use a bunch of telescopes and then upped the urgency after the first few views. So it went through 6 telescopes in a matter of a year. And these are all really, really famous telescopes. So first, it gets picked up by this one behind you. It's an array. There's several of these radio dishes. Then they wanted a little more detailed picture to see, like, hey, could this be a pulsar? Which maybe you can confirm this. Pulsars emit radio waves pretty heavily. Is that true? I mean, all the pulsar checks were done from radio observatories. So
Yeah, I mean the pulsars because they spin fast, and every time they fast, they just release a pretty much like a beep signal, a peak signal. So if you are hearing on the radio like saying beep 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 beep, and sometimes they change the frequency too. Well, first that they thought that an alien on a different planet is trying to contact us, because that was something that never heard from space. I mean, the signals can be varying, but the beep signals and the repeating beeps sounded like a very like a human made or some intelligent made form. So for that reason, they were pretty interesting. And the first they tried to decode the signals. Actually, this led the actually start of the SETI Institute, Search for Extraterrestrial Galactic Intelligence Institute. But it turned out to be actually the star that spins fast, and also it's spinning fast. It is moving electrons around, and moving electrons actually transmit radio signals. This is how we transmit radio signals all over the place. And this physical process, moving electrons in a loop, which they transmit a signal, and because the star is rotating, every time it rotates in one selective direction, we receive the signal. We don't receive all the signals, but as the star rotates, it is just throwing signals at us at a period. So that's when we say like beep, beep, beep in the radio, but it turned out to be pulsar. So I think it is very easy to identify a pulsar, because we just need to look for a uniform pulses.
yeah. Anyway, so telescope number 2 is behind you, the Parkes telescope. It's in Australia also. This gives them a little bit more detail to see if it was a pulsar, and it said not likely, but it was really an inconclusive study, so it didn't show it really well. However, they decided to move to another telescope. This one is the Meerkat telescope. These are located in South Africa. This is also radio telescope. It is a part of an array. We're only looking at one right now because this picture was so beautiful I had to use it. These are courtesy of NSF. And it said, yeah, it is definitely it's almost certainly not a pulsar that we're looking at. So this was our confirmation that hey, we need to move on. Then after they've gotten, this is the third telescope, they said we need to see, like, hey, maybe it's got a little more energy than that. We're gonna up it up in energy and check for X-rays. So they reached out to both the Neil Gehrels Swift Observatory and then this one, which is behind Levent, the very famous Chandra X-ray Observatory. And it's not probably a black hole. So to answer Lamia's question, turns out wasn't probably a black hole.
Yeah, black holes emit X-rays, X-ray radiation. And the first black hole discovered was called Cygnus X1 in the Cygnus constellation, and the reason it is called X1 because it emitted X-rays, or first they detected X-rays from a particular source in space. Later it was understood that was actually a black hole. So yeah, X-rays are good instruments to check to see if the object is black hole, but this one is not a black hole either. So what is it then?
One more, but they checked for one more thing. Somebody said, what if it was like a gigantic solar flare?
Which can happen.
What if a star near the center of the Milky Way just emitted like an absolutely massive solar flare? So
solar flare or star flare? I think we should say star flare here, because when I say solar, we are talking about our sun. Our sun has nothing to do with the signal.
Repeating what the research paper said, so maybe you should reach out to the researcher and tell them they change the wording. They use this is also just one telescope of the Gemini Telescope, which It's called Gemini because it's a twin telescope, so there's
Uh-huh.
two of them. These are in Chile, and these have a really good view of infrared, which would tell them if it was a solar flare, or sorry, stellar flare, or star flare, whatever you want to say. Um, and that wasn't it either. So yeah, the astronomers in the research papers all said we don't know what it is, and it now has become part of a group of objects.
I realize why you are asking this question to me then. You want me to find out what it
Yeah,
is,
yeah,
right?
yeah, exactly. You are a resident astronomer. They threw it into a basket of a galactic center radio transient, or GCRTs.
I have never heard that
It's just
term.
apparently there's a handful of things that
Uh-huh.
astronomers have seen come from the center of the Milky Way,
Yeah,
and they don't know what they are.
yeah.
Famous ones called cosmic burpers have happened a couple times, and other things.
Yeah, one of the challenge of decoding the signal is you said this signal is coming from the center of the Milky Way, and we are on the edge of the Milky Way. That means there is quite significant matter between the center of the galaxy and us.
Yeah, that's a good
That
point.
includes stars and stellar dust, which results in any kind of like light polarization, absorption of the light. Basically, a signal departs the object and then getting absorbed by some cloud or dust and re-emitted again, and every time it is absorbed and re-emitted, it is losing or changing its characteristics, and finally the signal is making to us, and it's like a puzzle because the signal changed form many times, and we need to go back and find out what was the original signal. So this may be one of the challenging, I'm not saying this is the case, but this may be one of the challenging of identifying that signal. But also it is always possible that we are finding something new, and this is how as I explained, the pulsars were discovered. And also there is an amazing story of discovering the cosmic background, which is
In the article or in the research paper, they actually talked about relating this to pulsars.
Mhm.
We don't know what it is. We
Yeah.
didn't know what a pulsar was when we first saw it either. We didn't know what a magnetar was when we 1st saw the
Mhm.
magnetic field around it. And
Exactly.
yeah, now they do.
And like with the some study done at Harvard, they discovered these great cosmic background, which is actually the static on your TV. Like I think the
Not
newer
anymore.
TVs don't show static. They go to blank signal anyway, or blank screen, and say no signal. But the older TVs didn't do that. Older TVs, when you don't have a signal that shows some program on the TV, they showed like a black and white snowy image, which was nonsense. But that is the signal coming from space. It exists anywhere in the universe, and that's called cosmic background, which is a 21 centimeter wavelength signal. And that was discovered by coincidence by Harvard researchers because they were trying to improve a communication system, and they caught that static, and they thought it was resulting from the electronics or originating from the dirty antennas. They did everything they can clean or fix electronics. They couldn't get rid of the signal, and they realized the signal was actually coming from space after they started using directional antennas. So yeah, we may be discovering something new, and I hope we do,
It's
because it's
definitely
always
interesting.
amazing to discover something new than discovering something already discovered before.
All right, I found a cool image of what you're talking about. This is what they use to find the CMB.
Yeah, this is what
map.
used for finding the cosmic background image. That's an antenna, if you are wondering.
So I see this Levent, and I just imagine somebody putting their ear up to it from the inside. It looks like a giant, like. Let me ask a really good question. And this is our last question before we have to head out today. So,
What's a pulsar? Okay, pulsars are pretty much neutron stars. Some stars have a lot of neutrons, and this is different story how a star gets a lot of neutrons or just completely be out of neutrons. But anyway, there are stars like that. And some of them, those are the results of big supernova explosions, because those were the stars very massive to begin with. So after an explosion, the explosion remains a very fast spinning object behind. So when an object spins, imagine neutrons or electrons, if exist, they are going into a circular loop. And if you know from physics, if you just spin electrons and neutrons at very high speed, after some speed, you will see that there is some radio signals bursted from the center of the spin, the circular motion, in the directions of axes. Okay, so that radio signals will be transmitted in the direction of axes, north and south side. So if you are here somewhere and listening, let's say, if you happen to be in that direction, you will hear a continuous radio signal that is coming from this object. But because this object spins and you don't have to be on the axis, if you are somewhere in that direction, or in that direction, which likely is, it's going to be a random direction, as the star spins, the direction of axis for the burst of the signal, or let's say signal path, would also spin in a circular motion. And once in a while, it will pass from the direction you are located, and every time it passes, you will get the signal, but the signal will disappear for a moment, because the signal path is pointing other directions at those moments, and it will come back to your direction and go away, come back to your direction, go away, and this will repeat. If you are listening on your, if you have like a qualified receiver, you will hear like beep, beep, beep type of signals. And that is what basically pulsar or pulsar signal is. All right, so
we have a cool little representation of pulsar beeping from all the pulsars we've discovered in the sky. We can show people. This is looking south tonight.
A pulsar is, the word is also, I think, the self-explanatory. It's coming from like the pulsating or pulses.
You can also guess. We were looking south, and then I just turned us slightly to the west, so like very southwest. Any guesses? You know what this is? What are we looking at? Why are there so many right here?
Well, you know, this is what we find out when we just mark some specific object in space, like with the when people say, which stars can you point? We have extrasolar planets, or extrasolar planets going around. We end up with a similar thing. So yeah, there are signals coming from space.
This
each
is
pulsar
the
is
Milky
located,
Way band that we're looking at.
Yeah. Yeah, especially we find them in along the Milky Way, right? So this is the path of Milky Way.
All right.
There are plenty of them.
That does it for our show today.
That, I think, sets the base for the radio astronomy, and justifies building all the giant dishes around the world, because there's a lot of cool stuff to listen, not only see.
Yeah, that's why those telescopes are so beautiful too. I mean, we moved back to not this one. This one is kind of cool looking, but look at that, it's beautiful. Just anyway, that's it for the show for today.
All right, sounds good. So find us on YouTube Friday, and then next week we are gonna be here on this platform Wednesday 1 p.m.
All right.
And if you have questions during the week, please let us know.
Thanks so much, guys.
Bye-bye.